Okay, I guess I'm starting. So let's begin. Please take a seat if you haven't yet. And thanks for coming, of course. Before the talk, I would like to let you know that if you have questions, please do ask them at slido.com, GeeCON 2019 room, and room number 1. And please do tweet your photos because you usually take photos and then I don't know where you put them. Maybe your family archive, maybe whatever it is, just drop them on Twitter, share with the rest who haven't made it to the talk. Please help spreading the word. So, about me. Well, first of all, the reason I'm talking about Testcontainers is because I am a co-maintainer of Testcontainers. The library was created by Richard Norris, and I joined the product. My daily job is I'm staff engineer at Pivotal, Project Reactor, and I'm also co-organizer of Berlin Spring User Group. If you're in Berlin, please come, or maybe you want to speak there, please reach out to me. And I'm really into development tools. So, before we start, I would like to focus on the theory and a short introduction to Testcontainers. Believe me, it will be short. We have a lot of slides, so I'll not focus a lot. Why it matters? Well, we all have seen a lot of fancy GIFs like this one. And, well, yeah, this door must probably have passed the task, the unit test, when it got produced. Then this thing also passed the test, but here we are. Yeah. Integration testing. So please raise your hand if you don't know what integration testing is. Cool. No hands. At least I can see any. So anyways, we can easily focus on why or how we can do integration testing instead of why. And before we continue, we should also highlight that, yes, even though integration testing provides a lot of value, like real-world isolated testing, or you can spot real issues, not just some issues you think exist with unit tests, but actually have some different ones, even before you go to production. Well, and it can be easily used during the development, unlike, let's say, system testing, where you need to spin up a whole fleet of services instead of just one in the isolation. Unfortunately, or maybe the downside of this approach is that you must start real databases. It should be cross-platform, because otherwise, if the test works on your machine and your colleague on Windows cannot run the test, well, that's not cool. It doesn't make the test more popular or doesn't force your colleagues to do the test during development. And of course, it's slower than unit testing. It cannot have the same time characteristics as the unit testing because, well, with unit testing, you simply run code. With integration test, you run a subset of a real system. So no surprise here. When we started the integration testing as an idea, most of integration testing scenarios were using mocks, and they were mocking some real environments and real databases, let's say, but it didn't work really well. So we continued with some local DBs. And some of you must probably have done a very long README of some project where it says, yeah, install MySQL, install Redis, install this, that, and that. And if you're on Windows, well, please find some other machine because we don't have this dependency on Windows like Redis. So it doesn't scale well as well. And we continued with VMs, and Vagrant was a blast. It was so great to have descriptor for the infrastructure that you can just run from a single Vagrant file, and then you can spin up your virtual machines with everything you need, like MySQL or Redis. But they are heavyweight. It takes a lot of time to run a VM. This is why Docker came to play, and Docker changed the game, because now instead of running VMs, we run like processes, not VMs, but processes. And it's much faster. And some people say that Docker is about the containers, and the innovation was in the containers. But the containers existed before Docker. What didn't exist is great tooling around containers. And what Docker really changed is it introduced a great tooling to manage your containers. This is why Fig appeared to kind of have the same experience as with Vagrant. You describe something in a file, and then with simple command, you start your databases, and boom, we get to Docker API. Because Fig was using the Docker API, and the descriptive nature of Fig, the downside was that, well, it's descriptive instead of imperative, and we cannot code our test requirements, but we can use some APIs, and Docker has an API. So for those of you who for some reason don't know what Docker is a great abstraction layer. You have a simple interface to run different containers on your machine, and then you have a great registry of existing containers like MySQL, get Postgres, I don't know, you want to run Node.js in a container, or maybe you need to run Kafka. Doesn't matter what is it, as long as it can be run as Linux process, it runs as Linux process. And it is CI friendly. Again, a common situation is, hey, dear sysadmin, could you please create another Jenkins node for me, and it should have MySQL installed, version X, then it should have Kafka, and most probably the sysadmin doesn't even know how to properly set up this thing. Your tests are failing, they run fine on your machine, nobody knows what happens. With Docker, the only requirement is our CI agent should have Docker installed. As simple as that. And it is cross-platform. Yes, we run Linux containers, but the tooling is cross-platform, and we can run Linux containers on Mac, on Windows, on Linux, of course, and even more combinations of environments, like running something inside the container already. One step back, Docker Compose. It's great. I mean, that's the only thing you need to run Redis, Postgres, and Elasticsearch on your machine. As simple as that. Just one file, a few lines of YAML, properly formatted, I hope, no indentation bugs, and you get what you want. Kind of cool. But it's declarative, as I said, and let's say we want to do port randomization. Yeah, yes, we can say ports 6379 for Redis, but then we will have to somehow find which port was assigned by Docker. Or what if we want to run one container per test, or we want to reuse Redis and Elasticsearch, but every test should have its own Postgres because we have migrations and we want to start from scratch. Or how about IDE integration? There are projects to integrate Compose with the IDE, but it's very limited due to previously mentioned problems. Docker Compose doesn't help you when it comes to Docker environments, because when I say it's cross-platform, it also means a ton of different combinations how it can run on your machine. It can be Docker for Mac, it can be Docker machine, it can be Docker for Windows, it can be native Linux. You may run your test inside the container already, you may run your test on CI environment, and so on and so forth. It sounds simple, but it's actually an incredible amount of combinations, and we have to think about all of them. So it's not a free food. And there's also, there's no place like localhost. We all got used to localhost. We know localhost, that's our home. But sometimes what we run is not on localhost. Yes. Guess what? If you run, let's say, on Docker machine, then some of you who tried Docker machine, you'll see IP something like 192, 168, 0, something, something. Surprise, surprise, it's not localhost. How can we improve it? And 4 years ago, the project was created named Testcontainers. And Testcontainers changed the game because First of all, that's the JVM library. It's not a tool, it's a library, which is really important because when it's a library, you decide how to use it. You decide how to code it, after all. And it wraps Docker Java library because Docker Java is a direct mapping of the API to what you get when you run some commands or something. Docker environment discovery, as I mentioned, is a hard challenge, and Docker Java does not provide anything for it, and it shouldn't because it's a lightweight wrapper. But in test containers, we do have support for all these combinations, and we constantly improve it. And another thing that's important is after you run your test, most probably you want to destroy the containers you created, and test containers takes care of it. And it is as simple as defining objects. You define new PostgreSQL container, and you have it. You define Redis container. There is no built-in Redis container in test containers because it's as simple as using a generic container, which is a common abstraction for any container you run with test containers. And you just need to expose the port. By the way, if you think that, hey, it's like too easy, we need more things, well, when you run generic container with Redis, it will also make sure that the container is properly started, that the container is listening on the port, not just your local host, let's say, has the port open, because on Mac, it opens the port even before the process inside the container starts listening. But test containers takes care of all of it. And if you're wondering, like, yeah, sounds cool, but is it really a big thing? Then this is a subset of our users, the users who decided to officially add them to the list of users on our website. And you can see some really big names here. That's only the list of the official users. There are also some unofficial users or who haven't added to the list yet. And you can easily find them on GitHub. And there are some huge names among them, like, I don't know, Google, IBM, and others. So they use test containers in their open source projects too. And you should. Another metric is a number of stars on GitHub. And no, we didn't pay anyone at that point, which was almost a year ago, a bit more than a year ago. It just happened naturally. The library is that popular. And we started with 900 stars in April, or in March, actually. And now we have 2,300 something. Impressive, right, for 1 year. Let's do a really short demo what test containers looks like on my machine. I have a simple Spring Boot microservice here, and I'm using Redis template, JDBC template, and Spring Cloud Feign. It has one endpoint, /me/city, and that's a geolocation service so that I can get my current location by my session ID. I'm not aware of Spring Security and other cool frameworks, so I'm just storing my sessions in Redis. And after I get my user ID from Redis, I run a JDBC query with my database. And after I receive the response, I do another query to Feign, with Feign actually, to another service. And this service is a geolocation service so that I can get city by latitude and longitude. I have a test here. And the test, we have the location we want to check. We create a user when we set up. We say that this user should be located in this location. And I check two scenarios. First of all, what happens if I query unknown user? And then what happens if I query known user and green flow? So in case of a known user, I'm not starting another service, the geolocation service, and I'm not setting stuff in his database. I'm just using mock server And in mock server, I say that when somebody does a query for the following latitude and longitude, then I should respond with CT Krakow. Well, and then I check that when I check /me/city, I get Krakow. I'm extending from abstract integration test. And my abstract integration test is as simple as this. I'm using standard Spring Boot testing functionality. It's not limited to Spring Boot, by the way, Testcontainers. You can run it with any framework or anything you want. Just in this case, I'm using it with Spring Boot. First of all, I need to set the data source URL. And I'm not even creating a Postgres container here. I'm just saying, OK, for the data source URL, I want to use JDBC, standard JDBC URL, TC, PostgreSQL, and the database name is GeeCON. What kind of sorcery is it? That's a magical driver in Testcontainers. And in Testcontainers, when you request a connection and your JDBC URL contains TC prefix, it will automatically start a container, and you don't even need to create these objects. It will be done automatically by the library. It's super convenient, and you can put this line to some, I don't know, application.properties or anything. So you don't even need to do a properties or something. And I have to set the driver class name. It will be added to Spring Boot soon, but at the moment, you have to hint Spring Boot that, hey, it should use this driver. You force the driver, otherwise Spring Boot will attempt to deduct the driver and will fail, basically. Then I define Redis. The same example as from the previous slide, and I define mock server. And this mock server, we have mock server module in Testcontainers too, but here I wanted to show that if something is not available in Testcontainers, you can easily create your own container. And this is how it looks, as simple as that. Mostly it contains with command, the image ID, and add exposed ports, and the rest is mock server specific. So when container is started, we create mock server client, and then we provide convenient methods like when or anything. So you can extend it, you can build your own types without having to contribute them back to the project. And I'm using static block here because I want so-called singleton containers. It means that this is a container that will last till the end of the JVM and will only have one instance, something like normal singletons in Java. It's Java-specific a bit, this static block, and you can do it with your preferred language or preferred way of starting. You can also use class rules if you want, but here I only need one container per JVM. And I start them in parallel. And as you can see, it's super cool that I can code the way I want to start it. Let's say in Docker Compose, when you want to define the order or anything, you have to use some Docker Compose parameters, or sometimes you can't even achieve what you want. But since Testcontainers is a framework, you build your containers the way you want, you start them the way you want, and we do have convenient integrations for JUnit, let's say, or for Scala test and others. And I simply set the properties. As I said, we are not going to start the geolocation service, but we will start the mock server. And here I'm setting list of service to the endpoint of mock server. As you can see, I'm not using localhost. I'm using get container IP address, and in this case, get first map port. That's just alias to get mapped port and first exposed port. And it's important to remember that you should not use localhost. Most probably it will work on your machine, but when you run it on Jenkins, it may fail. And believe me, you don't want to spend a lot of time trying to understand why it fails and then realize that, OK, I assume that it's localhost, but it's not. So please do not assume localhost. Now, if I run the test and I have Docker for Mac running on my machine, will take a few seconds. Here we're starting Spring already, and Postgres container started. And we have the tests passed, both tests. If we review the output, we see that there is some debugging output from test containers. It says different things like which strategy it's going to use. If you have problems, you see that it's not working on your machine. That's a great part to share with the team when you want to report an issue. Just tell us what was the output from this, that, and that, or just copy-paste this header from the logs. It says that it connected Docker. It started Rook. I'll talk later about it. And we see that it starts creating containers. And here we create mock server and Redis with our static block. They get created in 4 seconds. Later about it. And then we also start Postgres when Hikari pull starts. Because as I said, it will initialize the container first time you request a connection. So it will do it lazily. And if your test never asks for JDBC resource, then the container will not be even started. And we see the result as green test for non-user, and also green test with an error because we have special case covering unknown session. So all good here. It takes just a few seconds to run a test with Postgres, with Redis, and with mock server. And some may say, why don't you run mock server in process? Because mock service is Java project. Mock server, especially the old versions, were using some really outdated dependencies like Apache commands and others. And the more embedded things you have on your class path, the harder it is to manage your class path. And you end up with jar hell, most probably. One of the reasons why Elasticsearch folks said that they will no longer support the embedded Elasticsearch and use projects like Testcontainers if you need. OK, now comes the fun part. Apparently, not everyone is aware of the latest features in test containers. And now, if you were using test containers, this section is for you, because I want to quickly go through the latest changes in the past year we had, and there are some great ones. First of all, we added Kafka module, and running Kafka in Docker is not easy. Definitely not, because in Kafka, you must have port you must know the port up front. Otherwise, Kafka will redirect you to port 9092. And if you search for Docker Compose file for Kafka, most of them or all of them will have static port defined, because otherwise it's not possible. If you ever tried Kafka in Docker and Compose, you know what I mean. Then we introduced Rook. And Rook, oh, raise your hand if you know what Rook is. Not in test containers, just Rook. Exactly, it's from Death Note. That's a pun, and we wanted to make sure that every container we run, we will destroy it later. So we now have Rook, and then Rook is a sidecar container, very small one in Golang, consumes just a few megabytes of memory. And then every container we start, we send it to Rook, we record it in the Death Note, and then later, when JVM exits, Rook will kill every container recorded in his Death Note. Kind of cool, right? So we have our sense of humor. Anyways, in April 2018, we introduced Maven Bomb, and that was a huge pain, huge overdue, and now we have it. So if you're a user of test containers, please make sure you use Bomb. Don't define every version of every dependency from test containers you have, just import it. Yes, we do have Docker Compose, by the way. We do support running Docker Compose files, and we provide some convenient methods on top of it, like this one, wait strategies. Because in Docker Compose, let's say you need to wait when things have started, like really started, your database initialized it, not just started listening on the port or something. And that's the same API you would use for the generic container. Now you can use it with Docker Compose as well. Some users were reporting that there is a problem. Some threads are not daemon threads, and when you run test container as part of your, I don't know, fancy test, as a bean, let's say, in Spring session, that's one of the examples, then the JVM will not exit because there are running threads that are not daemons. Now we have daemon threads, and yeah, Kira thread, the same reference to Death Note, haha. And mock server module. Actually, my demo was before we introduced mock server module. So as you can see, we introduced more and more things, more and more modules. So it's basically the same code from the demo. In 1.8, we implemented OKHTTP transport. And before we were using Netty and just Netty. And the users were reporting that Netty has conflicts with their Netty version. We had to shade native libraries of Netty and a lot of pain, actually. But by introducing OKHTTP, we solved it. And we also started and did the first step towards test framework agnostic implementation. We do have a dependency on JUnit 4 still, but at least now you don't have to use JUnit 4 classes to start or stop containers, or if you need to integrate it with your favorite testing framework like Cucumber or Scala something or Kotlin something, whatever. Just as long as you implement these two, or this one actually, class test description, and make sure that if your test fails, you pass throwable as the last argument to after test, so that things like Selenium video recording will record on failure. And we also implemented Docker credential helpers, something you will not find in Docker Java, but this is important because more you use third-party registries, more you have problems with unsupported registry authentication in the Docker itself. And Docker is split into many binaries, and some of them are credential helpers. And we run them as processes on your machine and authenticate with the same mechanism as Docker CLI uses. And we also added copy file to container. Why, you would ask? Because once I was doing a demo, and I was saying that, yes, test containers can run on some remote machine, actually. And I had a remote machine running in Amsterdam, and I was presenting in St. Petersburg, I think. And I was presenting a demo where my container was using file system mounting. And the demo didn't work. And I was like, it must work. And later I realized, after the demo, of course, that I was using an instance in Amsterdam, and my tests were running just fine. Just this one was failing, but the speed was OK, everything was OK. So yeah, with copy file to container, we are not using volume mounts, something in Docker you'll be using with -v and then some paths. But instead, we copy them with Docker Copy API. It's fast enough, but helps you to overcome issues when you run your tests on some file system, which is not the file system of Docker daemon. And we added 3 more modules: Pulsar, Cassandra, and Couchbase. And by the way, Apache Pulsar was contributed, as far as I remember, by the Apache Pulsar folks, and Couchbase module was also contributed, or Couchbase team was involved. So we're really happy to see technologies contributing modules to test containers, not just us implementing them. We go forward, now September 2018, and after tests, we made the decision that now OKHTTP will be the default transport. We were using Netty by default, but then after 0 reports about any issues with OKHTTP, we finally did migration. It helped us to implement Windows npipe support. And if you were using test containers with Windows 1 year ago, most probably you had to turn on this nasty expose Docker daemon on TCP port, blah, 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 checkbox. And it's not secure, it's not cool, and you have to do a manual step. And we claim that with test containers, you don't need to do anything. You just run the test after you clone. Same for registry authentication on Windows, and we also fixed local Docker Compose on Windows. So a lot of love for Windows, as you can see. And when people say that test containers doesn't work on Windows, that's definitely not true. We constantly improve the experience, as well as Mac and Linux, of course. But we knew that on Windows there were problems, and we are solving them, and we do it continuously. And another feature, there was a really high demand, especially from QA people. We call it host post exposing. And the scenario is you have something running on your machine. Now you want to start a container, let's say with Selenium, and you want to test your, let's say, Spring Boot service with JSP with Selenium running inside Docker. Before, it wasn't possible because host network is not visible to the containers network, but now it is. And the API is super simple, as you can see. And we received a very significant contribution, random ports in Couchbase. And if you think that it was easy, it wasn't. Actually, principal SDK engineer from Couchbase was involved in the process, and we collaborated with them, making it work. Again, something you cannot achieve with, let's say, Docker Compose. And two more modules, ClickHouse from Yandex and PostGIS, nothing huge. Anyways, going forward, 1.10, finally, JUnit 5 support. I don't know how many users of test containers here. I believe that some, and we were receiving a lot of requests for JUnit 5. It's finally supported, and if you're using JUnit 5, please make sure that you use the JUnit 5 integration because it's great. And some JUnit folks were helping us too. New documentation. Well, that's not new if you're a user. If you're not, then be aware that our documentation is better than it was. So feel free to contribute to the documentation and request clarifications, but believe me, it could be worse. And one thing, small thing, but it helped to unblock some public CI environments like Bitbucket is an ability to turn off Rook. Another big pain, we thought about fixing it by changing Rook, and then we realized, okay, we are running on public CI. They have their own code to destroy everything after the test. Why should we spend time, and why should we care? Another performance optimization is support for shared memory configuration and TMPFS settings. Later, I'll say where we start using TMPFS actually in test containers too. And we turned on after dependency updates with Dependabot. By the way, it's not about test containers, but please start using Dependabot if you host your code on GitHub. It's amazing. It sends you pull requests for each dependency you have when it gets updated. Super easy, super convenient way to keep your dependencies updated. The only downside is that Dependabot has become the third biggest contributor to the project, and he even overcome our third co-maintainer, as you can see, Kevin. Two more modules now for Elasticsearch, nothing big. Now let's be fast with 1.11. That's the current release line, and we introduced chaos testing. Cool thing, really. I'll not focus on this slide. Just take a look and realize that you can add latency, you can interrupt connection between your tests and containers. A game changer for testing, and hotels.com did an article how they were using test containers for doing chaos testing, and there is also Apache Bookkeeper and Apache Pulsar communities. They have built their internal chaos testing tool suite on top of test containers, and they can run it on their machines easily. Remember I said we Oh no, okay, it's another one, but anyway, it's a good one. We turned off fsync for Postgres. Apparently, if you turn it off, you get a really significant boost, and just by updating to the latest version, you may get performance improvement just like this. The girl was me, the rest, like the family, was the rest of the community. They were like, why, like what happened? But we did drop netty. Nobody noticed, actually, but some noticed who were having issues with netty and netty dependency. Apparently, OCHTTP can solve any use case we have. It's much more lightweight. We shade it, and yeah, -5 or 6 dependencies just by removing netty. We did rework shading as well. So now the fun part, and people are leaving, and that's good for them, but they will miss the best part. Because now I will be talking what we were never talking about yet, and that's the roadmap. And I would like to start with the new DSL, and the new DSL is something we've been thinking for 3 years already, I think, and now we can finally show what we came with. It's not a complete rewrite, but it unblocks a lot of things. So what's wrong with the current one? Current DSL looks like this. And we have methods defined in generic container, in Kafka containers. This one is defined in generic container, And as you can see, the result of with startup attempts should be Kafka container, right? So we have to define with startup attempts somehow self-type-ish, so that when you chain your method calls, there will be no issues with the resulting type. And this is how it looks like when you open Kafka container definition and generic container definition. This self thing is super confusing, and we know, especially when you need to define a generic container, because, well, it doesn't work with Kotlin. It doesn't work with Scala. It causes a lot of pain. It's a legacy feature of Java, I would say, row types. But it works in Java. And when we were adding it, we were thinking about Java mostly, but we caused a huge pain to Kotlin users. So it's hard to maintain, doesn't work with Kotlin, Scala, and others. It makes objects externally mutable, and we cannot support something like setX or something, normal setters. We can only support wizards. And if you need to imperatively configure something, like if this system property otherwise set this, otherwise set that, it doesn't work. I'm happy to present what we came with, and that's our new DSL idea. What I'm telling here, it's not something already implemented, but that's the plan for future versions. And it can look like this, or actually, it may even look like this. That's a combination of 2 features, anonymous class and initializers. Some call it double brackets initialization. And if we do it like this, we can define every with set or something method as public void, because we don't need to return anything anymore. And be aware that some Java architects feel uneasy about this pattern, yet we were gathering feedback from the community, and nobody actually came up with a good idea why it's bad. So it's super easy to maintain. It works with any JVM language. It's controllable mutability, because we can assert that after we call initialize, nobody should modify anything anymore. And we can use void returning sets, and you can use if-else because it's just block of code, right? All right. Second thing is Graal VM focus. That's a good one, really good one. You can actually try it and read it already. Oleg Shilev from Graal VM, from Oracle, made an article. And apparently, you can already use test containers with JavaScript, with Python, with Ruby, even with R, I think. Any language supported by Graal VM, you can use it. You can use test containers in this language. Just read the article. It's easily Googleable, test containers, Graal VM. But that's a really nice one. Another thing, with a high demand was extracting container core, because current architecture looks like this. We have core where we have Docker, we have generic container, JUnit 5 integration, test lifecycle, and many more things. Then we have JUnit Jupyter, also known as JUnit 5, as a separate module, and we have many modules for technologies. In test containers too, we want to extract container core from test containers, and then we will have test framework integrations, executing engines, different executing engines, maybe even Kubernetes, who knows. And the modules will stay, so that you define your module with abstraction, so-called generic container or some other name, and then users decide how to run it, either in their tests or maybe in some super simple orchestrating engines for their infrastructure. So, I'm not an Apple guy, so I really fail at doing this one more things, but this one, believe me, test containers currently. We are flexible. We have great usability, and we have quite amazing features for a library. What really sucks is the speed. So we are somewhere in this area. And today I'm happy to inform you, not to announce, but to inform you that we managed, I think, to solve the problem of speed. And hereby, I would like to introduce reusable containers. Now is the time to upload, maybe take some photos. Yeah, thank you, thank you, thank you. That's amazing. And I welcome Sergei Egorov to the stage to present you reusable containers. First time ever, actually. Nobody ever seen it. Even some of test containers maintainers, actually. Anyways, I'm short on time. I'll do it really fast, but it's all about doing things fast, so it's all good here. So we have Kafka container here. Run Kafka container, and that's a very simple one. New Kafka container start, test Kafka functionality, send something to the topic, consume from the topic, verifies that what we send is the same as we consumed. Gretel, be faster, please. Yes, cool. Here we start Kafka. Container is starting, creating container for image, standard lines. And if we scroll to this part and we check how long it takes 8 seconds to start Kafka, because it's heavyweight. It really is, and yeah, it's not fast. And if you run your test on CI, then it's fine, right? You just run them. Another 10 minutes will not change anything. But if you're doing TDD and you run them on your machine, it's slow. We know it. And this is why we added this one line. Have you seen it? I can run it again. I still have time. I have 5 more minutes. I can run it millions of times, maybe. No, not really. I really suck at math. But I know things about containers. Anyways, now if we look at it, we see that it starts in less than 200 milliseconds. And it says that I'm reusing container with ID and that ID. I can do the same for Postgres. I can add TC reusable, I run it, boom. Less than 2 seconds in total. Big successful in 2 seconds. I even have the code here, started at and took this amount. So it took 1.5 seconds to start Postgres, to run the test, run select one, and to terminate the test. How cool is that, right? And how it works? Well, we maintain a pool of hashable containers. We take a hash of the configuration you provide. We take care of many nasty details, like what if this uses some randomization, what if custom containers defined, and so on and so forth. But anyways, we are taking care of everything. We are running a sidecar, and we monitor the containers, and we terminate them after some TTL. So it has time to live, and if you are not using containers for 15 minutes, they get destroyed. Then you start again, and you have them for another n minutes, let's say. It's configurable after all. And it's not something you would run on CI, right? This is why we have... OK. So first of all, yeah, as you can see, the containers are still running. And they started about an hour ago, because I have custom configuration right now, but anyways. And how to enable it, enable the mode with Testcontainers properties, of course. And here I said Testcontainers reuse enabled true. And now my machine will reuse containers. Your colleague's machine will not, unless he adds this line, your CI environment will not use reusable containers. And we'll make sure that it's super hard to use reusable containers on the CI environments, because you really should not reuse them there. It's super inefficient for the resources on CI. So, ultra-fast integration test-driven development, something we never seen before, like TDD, yes, but let's focus on integration test-driven development. You want to write a Kafka consumer, you write it, you run your test, you restart your test, and it takes less than a second to get working Kafka. It's minimal effort for the users. Like really, you add property to the property file, and then you define some containers as with reuse. Why not all of them? Because you may have a database state, and this database state cannot be reused. You cannot drop it, or you need to run migrations. This is why it's configurable per container. And you have to explicitly tell that it's reusable. And during the code review, your lead may ask, like, hey, why we reuse this container? We don't even randomize the table name or topic name or something. Make sure that you randomize everything, and make sure that 2 runs of the same test will not affect each other, please. It works for most of the containers. There are some cases where it doesn't. And we'll try to cover them as well. The biggest challenge is running networks and connecting containers into networks, but we'll solve it too. But it's not easy, and first iteration, we do it for containers, not for fleets of containers. It will eventually clean up stale containers, unlike Docker Compose or just Docker Run or any other solution you may have, which is great because when I'm using Docker Compose, for me it's a bit painful to run this Docker Compose down when my machine runs as crazy because I have a lot of containers running for different projects. And it will be available later this year. There is a joke about pre-order, but I would like to highlight that this feature is a proper enterprise-grade feature. Like in most projects, you get speed up for money, right? So you either slow or you pay for being fast. That's a classical story. In our case, we add this feature to the mainstream version of Testcontainers, open source. Testcontainers is an open source project driven by community, and we will not introduce something like Testcontainers Enterprise Edition or something. So we implement it, you get it, as simple as that. Takeaways. Testcontainers is a library that works on Linux, Mac, and Windows. Also on CI environments, various CI environments. That's not the complete list, but the most popular ones works just like that. Check the documentation about them, and provides a great balance. You literally can get all 4 now, or not now, but later this year. But I think you know what I mean. And if you ever did integration testing, you know the pain. Thank you. Thanks. So we are running short on time, and if the room moderators will let us to add 5 more minutes, then I'm happy to answer questions. 3 minutes. OK, we have 3 minutes. We would work on Jenkins that's already running on container. Yeah, yes, it will. It's even documented. See running test containers inside the container. Cool. Do you support MongoDB? Can't find it on modules list. MongoDB is as simple as Redis. There is example for MongoDB. Check examples folder, and you can just copy-paste the definition. But there isn't anything to add on top of generic container for MongoDB. Is there support for Groovy Spoke? Yes, there is Testcontainers Groovy project under Testcontainers organization. It does support Spoke, and Kevin, our third co-maintainer, came as a maintainer of Testcontainers Spoke, and then he joined the core project. Can you elaborate more on dropping native? GP has thread per connection model, which can be heavily some testing scenarios. Yes, I can. Testing usually is not like a super high-performant process. Most of the time, what's actually slow is your code or your databases. But to call a few REST endpoints and to run all of this, I need to run like 5 or 4 or up to 10, let's say, REST endpoints. We don't need something huge like native. And native is great, but for this use case, OHTTP is enough, and we can use npipe with OHTTP without having to go into native code, which we have to do with native. What's about reusable containers share between tests? Yes, you can use a reusable container between tests, different projects on the same machine, as long as the hash is the same. There is also a locking mechanism, so that if you acquire a container for one project and you run another project in parallel, that project will not get a reference to the hashed container. So we have locking, global locking of containers. Can I run Kafka purely in RAM? I just love my hardware too much and I don't want to lose it. Yes, we even have some optimizations in Kafka container definitions that help us to run it faster, less flushing, less stuff. And you run it in isolation, in Docker, and you can tune Kafka too. But we are not running embedded Kafka project inside the container or anything. But we could, by the way. What container backends, Kubernetes, Rocket, are supported in Testcontainers? Currently, it supports Docker. We operate with Docker API, and with Testcontainers 2.0 and Container Core, we plan to support maybe Kubernetes, maybe Rocket. Rootless containers is a big priority, so that you don't have to install something with root privileges too. I had problems with Postgres Container API. How do you set the DB server? I have found a way, but it reads the DB server from the GDBC URL, the one you specify, or at least it should. Just update the version. There was open issue, and I think it's closed now. And latest one. Could you get rid of gene dependencies sooner than TC2? I have a better idea. Let's focus on TC2 and let's spend our power on TC2 instead. And it's closer than you think, actually. Boom. Thank you.